Hi everyone, welcome back. Let's write some more Leetcode today. Today we are solving count good triplets in an array. So the problem states that we are given two arrays. One is called nums1 and one is called nums2. And both of them are permutations of 0 from all the way to the length of the array minus 1. And we know that a good triplet is a set of three distinct values that are in increasing order in both nums1 and nums2. And we want to return the total number of good triplets. Okay, so if we look at these two examples, in example 1, the output is 1 because the only triplet that is increasing in both arrays is 0, 1, and 3. As you can see, right here it's increasing, and 0, 1, and 3. And in example 2, we have 4 triplets, which is 403, 403, and 402, 402, and 402 right here, 413, and 412, which happens here. So we return 4. So now that we have seen some examples, let's get to how we can solve this problem. Before we get to how we can solve this problem, we will need to know how to convert a number from positive to negative in binary form. So what we will need to do is flip all the 1s to zeros and all the zeros to 1s, and then we just add 1 to the binary number, and that will be the negative form. And this is important because when we solve this problem, we will need to perform an AND operation for the number and the negative number of that number throughout this problem. And to perform an AND operation, basically, if the digits have both 1s, then we leave it as 1. Otherwise, if one of them is 0 or both of them are zeros, then we convert them all to 0. And the reason we may need to know that is because for this problem, we will be using a binary index tree. So if you're not familiar with that, please look that up first. But basically what a binary index tree can do is to save some time. Rather than iterating through the whole thing, it can just iterate by the power of 2. So we will use a binary index tree to calculate the prefix sum. Now in the beginning of the problem, we will initialize the array position 1 and position 2 to 0 times the length of nums1 and nums2. And we will use this formula to fill out position 2. And we will use this formula to fill out position 1. So for this example, it will end up looking something like this. So position 2, it will tell us that 0 is at index 2. 1 is at index 1, 4 is at index 0. So in position 2, we just flip the index with a value. And in position 1, it will tell us that 4 is at index 0 in nums2, 0 is at index 2 in nums2, 1 is at index 1 in nums2, 3 is at index 4 in nums2, 2 is at index 3 in nums2. After making these two arrays, we will iterate through the position 1 array, and then at each iteration, the index that we are on, we will treat it as the middle value in the triplet, and basically we will look for the number of valid values on the left that could make a triplet, and the number of values on the right that could make a triplet. And then we will multiply left and right, and then add whatever the product we have to the result at each iteration. So how we can do that is, in each iteration, to find out the left, we will use this query function, and then afterwards, we will need to update the binary index tree, and then we can use this formula to find out the number of values on the right. And then we will continue that until we get to the end of the array. So let's go through this example real quick. Now, I'm not going to go through step by step the query function and the index function, but you guys can track it on your own if you want to. But first, we will start at index 0, and we realize that the left has 0, and we need to update the tree, and then the right has 4. And 4 times 0 is 0, so we don't add anything to result. Now we look here, we realize the left has 1 because 4 is on the left on both sides, and the right has 2 because 2 and 3 are both on the right. And then we also need to update the tree. 2 times 1 is 2, so the result is 2. At 1, there's also 1 on the left and 2 on the right. So 2 times 1 is 2, and again we add 2, update the tree. And 3 times 0 has nothing, but we still need to update the tree. And then we come to the last iteration, 3 times 0 has nothing again, and we just update the tree. And now we are at the end, so return the result of 4. And the time complexity would be O of n log n. The n would be iterating through position 1, and at each iteration, it may take up to log n time to iterate through the binary index tree, and the space complexity would be O of n because the binary index tree and these arrays will all only take up to n space. So now let's get to the coding part. Alright, so first we'll set up the tree class. So constructor will have size in it, so self size, and self.tree will be 0 times size plus 1. And now we will write our update function. So self of index, and first we will add index plus 1. And while index is less than the length of the tree minus 1, then we will add the value at that index by 1, and then we will perform an AND operation between the positive and negative number of that index and then add it by the result of that operation. And now we will write the query function. So again, index plus 1 and result is set to 0, and while index is greater than 0, we will add the value at that index to the result, and then we will subtract by the index by performing index and negative index operation. And then finally we will return result. And then now we can get to the main function. So we'll set n to length of nums of 1, and we'll set position 1 and position 2 to both 0 times n. So the length of it will be n, 0 times n. And now we need to figure out the position 2 array. So for I and num2 and in array num2, position 2 of num2 will equal to the index, so I. And for position 1 array, we will do I and num1 and enumerate nums1, and we will do the position 1 of the position 2 of num1, and then we'll set that equal to I, the index. Now we'll initialize a tree, so tree equals tree with size n, result initialized to 0, and now we will loop through n. So position will be the position 1 value, and then we will do a query on it, and what we return will be the left. And then we will need to update the tree, and then we can use the formula to figure out what's on the right. -1 minus position minus the value minus the left. And then we can add the product to the result and then return result in the end. See if it works. Okay, perfect. Thank you guys for watching. Hope this was helpful. If you have any questions or comments, feel free to leave it down in the comment section, and I hope to see you all again soon.